This there are two topics. One is propagation in air distances, and propagation in far distance. To calculate the propagation in air distance, we are taking 1 m intercept, right? We are taking 1 m intercept. Here the antenna height is 30 meters or around 100 feet. If we increase the antenna height up to 60 meters, that is 200 feet, a 60 dB gain is obtained. And from 60 to 120 meters, under 60 dB is obtained. That means for each 60 meters, the gain is up to 60 dB. Right? At the same time, if the antenna height is 400 meters, which is equal to the free space signal, which is equal to the free space. Is equal to the free space signal, right? That means if the antenna height is 400 feet and the free space, in both cases, the mobile receiver signal is same. And at the same time, the vertical plane of the antenna is different, and also it is non-isotropic. Also it is non-isotropic, right? Here, the 6 dB omnidirectional antenna beamwidth. Here is the 6 dB omnidirectional antenna beamwidth is here. This is discussed in the last class also, which is decreasing. That means the antenna beamwidth is reduces and the theta is increasing. When the theta is increasing, the antenna beamwidth also decreases. Right? Omnidirectional nothing but in all directions. Right? This the reasons for using 1 m intercept. That means we are taking reference as 1 m. One of the reasons are if for the land to mobile propagation. That means if a signal is propagating from land to mobile, the antenna height at the cell site, the antenna height at the cell site affects the mobile reception. Right? That means the antenna height plays an important role in land to mobile propagation. And for M1 MI mobile reception is away from the refer to a given base station. Which depends on the antenna height. Whereas the surroundings nearby the cell site can also decides the reception level. Mobile signal reception level either upwards or downwards. If the surroundings at the cell site are normal within the 1 m receipt, 1 mm intercept, then the signal is very high, the signal strength is high. If the cell site is 1 mm away from the mobile unit, then the effect is negligible. Right? These all are the reasons for selecting 1 mm intercept. That means 1 mm radius. Also, based on this table, we came to a conclusion that if the antenna height is around 19 meters, then the incident angle and the elevation angle both are high. And also the attenuation alpha is also high. That means we have to increase the attenuation. Sorry, we have to decrease the attenuation level for a better signal propagation. Right? Whereas if the antenna height is around 60 meters, then incident angle and elevation angle both are 21.6 and 20.75 degrees. And the attenuation is 16 dB. And in the same way, if the antenna height is 30 meters, the both incident angle and elevation angle, it means both theta and phi. These are called ground incident angle and ground elevation angle. Where here one angle is with reference to mobile unit. Right? Here the attenuation is very less. Here the attenuation is very less compared to remaining. As long as we will calculate the near field propagation by using D. D is equal to 4 H1 H2 by lambda. H1 H2 are height from ground to cell site. H2 is height from the ground to mobile unit. Where lambda is wavelength, right? Here delta pi is equal to pi. By using this formula, we will calculate the DF value. We will calculate the DF value. If the signal received within the near field, that means D less than DF, we are using free space loss formula. And if the signal received outside the near field, that means D greater than DF, we are using mobile radio path loss. The mobile radio path loss. Which is near distance propagation and long distance propagation. For long distance propagation, we are using high antenna. Whereas the advantage of high cell site is it covers and the signal covers a large area. Right? If you are calculating within a area 50-mile radius, 50 mm radius, a low atmospheric phenomena will be used here. For the less than 50 mm radius, the wave path can be either upward or downward. The wave path can be bend either upward or downward, right? For that, you will experience sometimes you will get the strong spot or it may be a weak spot. Now, at a distance of 20 mm or 320 kilometers, here we are called it as a tropospheric propagation. In tropospheric propagation, the wave may be divided by refraction reflection. Coming to tropospheric reflection, it is a gradual bending of the rays. That means the signals are gradually bending due to dielectric constant, changes in dielectric constant when the wave is passing. When the wave is passing. Whereas in other one is tropospheric reflection. The reflection will occur where there are more changes in the dielectric constant of the atmosphere. Changes in dielectric constant at the atmosphere leads to tropospheric reflection. Right? Tropospheric refraction, tropospheric reflection. Here, we are going to discuss about the general formula for Lee model. In the starting topics, we are discussing that the Lee model is used to use as a predictive model. The Lee model is used as the predictive model. Right? Here is a general formula of the Lee model. Here, which is the Lee model is mainly used for point-to-point model. And the general formula is stated in three cases. Three cases. One is the direct wave case. In direct wave case, the antenna height is a major factor. And in this case, the location of the mobile unit is plays an important role because the mobile unit is traveled from one area to another area. The antenna heights may be different from one area to the area also. In the direct wave case, the antenna height and the location of the mobile unit plays an important role. The second one is shadow case. Here, the antenna height not an effective plays not an important role here. In the shadow case, the loss is due to knife edge diffraction. Knife edge diffraction loss. due to effect diffraction loss. And third one is over the water condition. Here in over the water condition, the free space path loss is applied. Free space path loss is applied. In this, there is a formula for received power for non-obstructive path. That means you cannot, if you don't have any obstructions here, then this formula will be applied for non-obstructive path, which is P suffix R naught minus government log R by R naught plus 20 log H1 A by H1 plus alpha. Here there are two parts in non-obstructive path. One is human made structure. Human made structure is nothing but where a open area or a sub-open area, suburban area like this. These are called human made structures. And the second part is comes under terrain contour. Terrain is nothing but the natural terrains. There may be hilly top terrains or on the water. We will calculate the received power of a signal by using this for non-obstructive path. Whereas coming to obstructive path, in obstructive path also the human made structure is same. In obstructive path also the human made structure is same, but in natural terrains we are using the different formula by adding L here. Okay. Where the land to mobile over water is equal to a free space formula. We are using the same for a free space or land to mobile over water. Here are the formulas for Lee model for obstructive paths and non-obstructive paths. Right? And also some remarks on this formula. That means the received power P suffix R is not higher than the free space loss. The received power is not higher than the free space loss. And also where alpha is the correlated factor. Where this alpha is calculated from the standard conditions. We are already discussed the standard conditions. Right? For Lee model, the first one is the standard condition, second one is area to area, obtaining the area to area predictive model, third one is obtaining point to point predictive model from area to area predictive model. This we are discussing 5 standard conditions there. We are taking the alpha from them from there. And the other one is the foliage loss, which was discussed in the last class. Is also added. Foliage loss will be added depending on the individual cases. Depending on the individual cases, we are not avoiding. Okay, sorry, we are avoiding the forest areas, because in forest areas no signal penetrates through a forest because there are many trees and leaves are there. If we calculate the foliage losses in forest, the signal loss will be very high. So we have to avoid the cell site in the forest, right? By considering the foliage losses, the antenna height should be high than the top of the trees. The antenna height at the cell site is higher than the top of the trees, right? These are other remark about foliage losses. And one is from correlation factor alpha. This is taken from standard condition. And also the received power cannot be higher than the free space loss. Cannot be higher than the free space loss. Another one is within 1 mile, the receiver signal is affected by the buildings and street orientations. The prediction formula cannot be used in such areas where the receiver signal is affected by the buildings and street orientation. Cannot apply the macro cell prediction model. Right? The other one is the merits of the point-to-point model. Whereas the area-to-area model provides only the accuracy with the standard deviation of 8 dB only. Right? Whereas the point-to-point model decreases the uncertainty range from the path loss prediction by using the path loss prediction. And also in predictive models, there may be differences from predicted values and measured values in many areas. And also some merits are there. The point-to-point model, whereas the point-to-point model is useful for designing the solar system with a cell radius of 10 mi. Cell radius of 10 mi. And also the point-to-point protection can be used to provide the overall coverage of all the cell sites. The main theme of the point-to-point prediction model is to provide the coverage for all the cell sites. It should also avoid the co-channel interference. To avoid the co-channel interference. The point-to-point prediction model is a basic tool that is used to generate a signal coverage map. Right? These are the use of point-to-point model. Right? This is about the Lee model. Coming to previous topic. The cell coverage can be based on a signal coverage or a traffic coverage. The signal covers entire area, then the cell coverage is completed. Otherwise, the cell coverage is not 100%. The service area will be calculated, or service area will be predicted by based on two environments. One of them was government structures, other one is the natural terrain.